Welcome everyone to Lesson 2 on this crash course on mixed model material management. I'm Richard Ron with the Leonardo Group. I'm here with my colleague,
Gerard Leone with Leonardo Group. Thank you all for being here, and make yourselves comfortable. Grab a cup of coffee because we're going to be moving at a pretty high rate of speed.
Yeah, this is going to be a really cool one because we're going to get into some actual tools and hopefully things that you can just take away from the session and go apply. Even if it's just a pilot area, try some of these things out.
And one of the things we want to do is as we speak, as we talk about some of the tools, we want to give you some practical recommendations for you to go and try these tools and start to implement them. And then again, in a pilot mode, as Richard just said.
Okay, so before we continue, let's just review quickly what we talked about in Lesson 1. We want to assume that you watched it, but if you didn't, right on this page, there's a link and you can watch it. So suggest maybe you stop this one, go watch Lesson 1, and then come back to this. We won't go away. We'll still be here when you come back. But what we talked about was really making the case for the importance of material management. I don't know that we needed to convince you of this. I think pretty much we're all bought into this reality. But the fact of the matter is that for most companies, not everyone, but for most companies, materials are a couple things. Materials are, number one, the biggest item on your balance sheet. Now, unless you're Apple computer or Microsoft where you have a huge amount of cash, typically inventories are a big chunk of the so-called assets on your balance sheet. So that's one important thing. So what happens actually, just a side comment, when you reduce those assets without reducing your customer service, what happens is those so-called assets of inventory become cash. And cash is a lot more flexible. You can do a lot more different things with cash than you can with inventory. The other thing about materials is it's the biggest part of your product cost. Again, this isn't always true. If you're making toilets, maybe your materials are clay and some other chemicals, but maybe your biggest costs are energy in that example. But for most discrete manufacturing, materials are the biggest part of the product cost. Gerard, what would you say for example, cell phone? So here's my cell phone, which I turned off, by the way, reminder.
Yeah.
Here's a cell phone. What percentage of the product cost in the cell phone is materials?
Easily 75%.
Yeah, or more, right?
More, yeah.
Or more.
In high-tech products, it's a very, very high portion of the cost. And that's something that you have to consider in optimizing your materials management system. And again, please notice that we're not using the term reducing inventory. We're talking about optimizing, because last thing you want to do is to run around taking materials away from the folks that are trying to make product and leave them without materials, which brings us to the third point we made during the last video. And the other reason that why this is so important is because materials is the number one complaint that you will hear from the folks on the floor. If you go to the floor and ask the folks that build the product, what is the number one pain point? Rarely anybody would say something like, well, the people here don't know how to build a product, or the line is not well balanced. You may hear those. Is not going to be number one. By far, number one is going to be, well, we could build stuff if we have the product, if we have the parts. We hear this all the time. So
and there are two ways of not having parts. One way is your supplier didn't deliver them, so that's one whole kettle of fish. And the other one is you had the parts, but you couldn't get them where they needed to go in a timely fashion, in the right quantity or the right item, etc. So two things to juggle and keep in the air when it comes to material management. So I think you're all convinced, hopefully, that this is a huge opportunity. In fact, for many companies, it's the low-hanging fruit. It's the easiest to harvest fruit of benefits is related to materials.
And sometimes not seen, because sometimes management tends to have they have the predisposition to go look for savings in labor, rather than in materials. And in materials, there's a lot of money in most places that we know anyway.
Okay, so thank you for your comments so far. There's, again, a space on this page that you're watching now to add comments, so please keep them up. We're looking at them. We're reading them. And what we'll do now is just head into this meaty topic, which is the what. So what are the techniques? What are the methods? Because lean companies do things differently. than traditional manufacturing when it comes to materials. And that's what we want to focus on. What are the different techniques, the better ones, the best practices when it comes to material management in the world of lean? Okay, so let's recap the opportunity. What is it we're trying to accomplish here? And then we'll get into some tools, some ways of actually accomplishing these benefits. So opportunity number one that we can mention is, and maybe this is the most important, we want to improve the dependability of delivery. And there's a category of dependabilities, different types of dependability that we want to achieve, sometimes called the 7 rights. Let's see if we can, of material management, let's see if we can list them all from memory, not looking at my notes. Actually, I don't have them here on my notes, so it has to be by memory. So we want to have the right part, right, at the right time,
Yep.
in the right quantity, in the right sequence, if that's a concern, in the right order, in the right container, that's 5,
Location.
in the right location, right, to the right spot, and
At the right cost.
the right cost. Beautiful. So those are the 7 rights. Okay, so that's benefit number 1 that we want to achieve. Benefit number 2, improve, what we have listed here, improve efficiency of material management. So what we're talking about here is, it's one thing to get the material to where it needs to be in the right quantities and so on. And then the other concern is, how do we do that efficiently? Because you could have an army of people doing that and accomplish part of this, but not at the right cost, right? The cost of doing that. So we want to make sure that we design a material delivery system that's efficient, right? That is able to do it with a minimum of input.
And part of that efficiency is to ensure, which is our next benefit, is to ensure that the folks that build product have the material to build product so they don't have to spend time on indirect activities like fetching parts. You want to keep the hands of the operator on the product as much as possible. And for that reason, you need a well-designed material system that will provide the supplies or the materials that are needed to the operators when they are needed, so they don't have to get their hands off the product.
So how many material handlers do you need? Well, it might be more or less than you have today. And so that's sometimes a sticky point with management when you talk about adding material handlers. So we'll be addressing this in a little more detail.
We'll talk about that
up.
in just a few minutes.
Right. Now here's a third potential benefit. And this is, again, one that's somewhat ignored often, and that is improving the operator productivity, operator efficiency, the people working on the line. Because remember, for every material handler, you probably have multiple operators. It's not a one-to-one relationship. And so if you can do things that improve material handling but degrade the operators, you're going in the wrong direction. So what we'd like to have is a methodology, techniques, methods that actually help the operators do their job, as Gerard just mentioned, so they don't have to walk, so they don't have to look, so they don't have to wander away from their station to get parts, etc. And that's all too common. If you videotape your line, you might see quite a bit of that taking place. A lot of wasted time in part selection, in part retrieval, all of those things. If we can improve those things and have a positive impact on operators, that can be huge in terms of the overall impact.
And that is much more common in lines that are not properly designed. Because when you design a line along with its material management system, what happens is that there is cooperation. When there's cooperation, there's not this fight between these two organizations, right? Where operations is concerned with the productivity of the operator, while materials management doesn't care about that. They just want to reduce their own costs. What you have to be focused on is the overall cost. And we'll get a chance to talk about that in just a few minutes.
And then the last point we wanted to make was the impact on floor space. Obviously, materials occupy a lot of floor space. If you don't do it right, then you're really consuming prime real estate. It's not real estate in a warehouse. That's less prime real estate, but you're occupying production floor area. And that is really prime real estate, and you want to minimize that.
Interestingly enough,
use it effectively, let's say.
Interestingly enough, that's a pretty common call we get. Could you come take a look at our plans, because we're running out of space and we're thinking about moving to another plant. We're thinking about adding. We're thinking about building more. we take a look, and more cases than not, the answer is, well, listen, need to look at this deeper, but if it was my money, I wouldn't be writing you a check to go build another place until you make better use of this one you have, because there's material all over the place.
Yeah, I mean, I think what we often say is we'd love to tell you that you need to build a new building, but not until you've optimized the space you have. That'll be a nice problem to have. You've really optimized the space you have, and you've got to build an addition. I mean, even Toyota has to build additions, right, at some point to their buildings. We know about that. Okay, so the good news about all of this and achieving these benefits is it's really not that hard. We're not talking about designing the Atlas rocket or anything like that. This is all pretty straightforward, but it does require what we call, or what Deming called, constancy of purpose. In other words, don't give up. Right?
Exactly.
Stick with it.
We hear more often than not, and we don't hear this in manufacturing that much anymore, but we used to hear it because we've been at it for many, many years. We used to hear this thing of, well, we tried Kanban, it didn't work. Well, not really possible. Kanban does work. Now, is it the 100% solution? No. And nobody would ever say that. Nobody who knows anything would ever say that. But once you learn the tools and you implement them, you must stick with them. You have to stay the course and learn to optimize them and learn to make them more efficient, so you can be successful at them.
Okay, so I think we've summarized it. One last benefit, of course, is for you personally as a material management professional. Because if you get good at these techniques and you can have an impact that's fairly large on your organization, then you're a valued person, right? Career security, let's say.
And what we're talking about here is not just being a specialist on Kanban calculations or being an expert in materials management or an expert in purchasing or materials planning. We're talking about being an expert in mixed model materials design systems. Learning to design a material system that supports a mixed model line. That is what we're talking about. That is what's in high demand these days. And quite frankly, that's something that is not taught in college. So good news, bad news, right? Bad news, you got your engineering degree, you didn't learn that. Good news, you can learn it without going to engineering school.
Let's start with the first quintessential lean material management tool, which is Japanese word Kanban, which I'm sure you've heard before. So we can't talk about methods and techniques without mentioning Kanban. We'll start with that. So the definition of the word Kanban, if you do a Google search on Kanban and search for images, what you're going to see is billboards, Japanese billboards, or signs. So I think that's the original meaning of the word, but better translation for us is signal. So when you hear the word Kanban, just think signal. Various types of signals that we'll touch on in just a moment, but Kanban means signal.
And signal for what? It's signal for materials replenishment. That's what it is. You run out of materials and you post a signal, and that signal tells the materials handler, bring me some more. How many? We'll talk about that in just a few minutes.
Yeah, could the signal be electronic? Yes, but more typically we're talking about something you can see, something you can touch in the form of an empty bin or a card or a light, something that's tangible. That's what we mean by signal. But as I said, it could be an electronic signal as well. So a couple different types of Kanban that we want to just touch on. We could spend all day talking about this, but let's just review the basic Kanban methods. There's more than one. And of course, part of your job as a material management professional is to pick the right tool. It may not be Kanban at all, but if it's Kanban, what type of Kanban? So let's go through them. The classic one that we've taught for years is what you might call the two-bin Kanban. It's a really simple concept. You have two containers, they have the same quantity in each, and you consume out of one at a time, not out of both. And when that first one's empty, that's the Kanban signal. That's the signal. Go refill it. Now, while it's being refilled, you don't want to be waiting for it to come back or stop. Ergo, you have the second bin. So you consume out of the second bin while the first one's being refilled. And if this is all working well, that first one comes back before that second one is empty, and so on and so forth, right? Ad infinitum, right? You just cycle through those two containers back and forth. So what could be simpler? And that's
Absolutely.
a classic
Common,
and common technique.
very common, simple implementation. Now, if you take that system and now you overlay on it a standard container or standard container size, it is unlikely that in every case the number of containers is going to result in exactly a number of 2. So you may end up by taking a Kanban calculation and dividing it by your standard container size, and you end up with maybe 3 or 4 or 5 containers. In that case, we're talking about the multi-bin system, where each bin is a signal. This is a much more common application for companies that want to standardize the container size, and that's something we actually do recommend. It's a very effective system, and it makes the line much more tidy material presentation due to the fact that you don't have a million different types of containers.
And the logic is the same as the 2-bin. If the bin is empty, then just go ahead and refill it. Right? You don't have to wait, just send the signal and get it refilled. But in front of you at that station, you may have more than 2, is the main point.
Now, if it concerns you that, well, now instead of having 2 signals, I have 5, yeah, you do. And when in a few minutes we talk about shortage proofing your line, we're going to be talking about increasing your delivery frequency. And that really matters, because that will help you protect your line against shortages. And the more containers you have, the more frequent the replenishment, the more granular the replenishment, the less the likelihood of a shortage. So we'll get to that in a few minutes.
Okay, so here's another type of Kanban, and this is similar to the multi-bin that we just talked about, but it's used in a little bit different way. So imagine you have a machine with a changeover time. And the basic challenge you have with machines with changeovers is that if you set up those machines too often and run batches that are too small, you run out of capacity. You're just setting up all the time. You're not actually producing. On the other extreme, if your batch sizes are too large, then you're setting up less frequently, but you have a lot of inventory. So what you want to do is strike a balance. But with Kanban, here's the trick. You may have more than one bin, but you can't simply send the signal and set up and run to fill one bin if that's not the batch quantity. So you may have, and we call this multi-card, you may have to wait and accumulate a certain number of cards or empty bins before you could set up and run. So you're not running a batch that's too small. That's the issue. So similar but different. You have to have a way of managing these cards and bins. You have to have a system in place so that you avoid that issue of running batches that are too small. But another use of Kanban, right? Another manual system, a manual scheduling system in a sense.
Yeah, and there are a couple more Kanbans for you to consider, but they are not really part of materials management. And one of them is the in-process Kanban, which is a signal to work or flex on the line that is normally placed in between workstations and indicates to the upstream workstation when to work. If it is empty, build one more unit. If it is full, that may be the signal to flex downstream. So the in-process Kanban really, it tends to be more within the realm of line design, mixed model line design, or process design, rather than mixed model materials management. And another version of the in-process Kanban is the FIFO lane. The FIFO lane is multiple in-process Kanbans, and of course they have to work in a first-in, first-done manner. So sequencing, the scheduling sequence is kept intact.
And a FIFO lane or even an IPK could be of use if you're sequencing material. So you're delivering material one at a time for a specific unit, for example. Where do you put it? Well, you might be putting it in a FIFO lane, and that would avoid over-delivery, right? And when you have a signal, bring me another one, the next in the sequence, that kind of thing. So the main point of all these tools, all these Kanban tools, is that we're setting up a a pull system, meaning if I consume the material, then bring me some more. And that's as opposed to a push system where the computer schedule says I need this material, so go deliver it to the factory floor. The problem with push is that when things change, the system may not be running real time and really know that. And what inevitably happens in push systems is you accumulate inventory that you don't really need at that moment. So pretty much what you want to do whenever possible, and sometimes you simply can't, but whenever possible, you want to pull material to the point of use.
And since Richard's touching up on a difference between a Kanban system and MRP scheduling of materials, pushing materials to the line, another important difference is the fact that every time you run MRP and you calculate your material needs and those are sent to the line, that tends to be done on a fixed schedule, once a day, once a week, once a whatever frequency, but the frequency is fixed. What varies is the amount of inventory being sent to the line. Kanban is exactly the opposite. Kanban is a fixed quantity at a variable interval. So that's very important because that will keep the amount of inventory at the line at a minimum rather than receiving large quantities of materials that, as Richard said, in many, many cases are not needed for a long time and they sit there.
Okay, so that's the crash course in Kanban. There's a lot more we could say about it, but I think that gives you a pretty good feel for that. Now, in most or in many environments, the Kanban method could be used for 50, 60, maybe even 70% of the items that you have to manage may be good candidates for the Kanban method. So it depends on the frequency of usage. It depends on how much variability of items you have to manage. But in many discrete manufacturing environments, Kanban is the most common method for getting parts, especially smaller items, to where they need to be. And then you deal with the exceptions. And the exceptions could be infrequently used items, so once a month or once every few weeks, probably not a good Kanban candidate, or very large, very heavy items that have to be handled one at a time, not a good Kanban candidate, or options and unit-specific types of material, or sales order-specific material that you simply can't control in a repeating kind of way, right? They're unique. But 60 or 70%, is not unheard of. So it's going to be a big part of your lean material management strategy, is Kanban. All right, let's talk about some of the other tools and methods that we need to include in our toolkit. Okay, so here are some other tools. We will go down the list that are, I wouldn't say exclusively lean, but typically found in a lean material management kind of environment. And the first one is a focus on containerization. That is the right size containers for the material. Really important consideration.
And this is something we see so often. We go to a line, we go to see a new client, we go check the line, and we see this a lot in our hospital clients, that you see enormous containers with just a couple of parts inside, or you see parts that don't fit, or containers that are overflowing with parts. In many cases, that's the result of just not sizing the containers right, not having a good containerization strategy.
Yeah, or cardboard boxes, using cardboard boxes, and you can't see what's inside of them. Mm-hmm. So many times we open a cardboard box, a big one, and there are a few parts in the bottom of the box, but you can't see from the outside the status of that. So in general, when we talk about containerization, we're talking about moving from larger to smaller. Now, you might ask yourself, if I go to smaller, doesn't that mean more frequent delivery? Yeah, it does, because you're not going to have as much material there. You're going to have to refill it or replenish it more often. But the benefits way offset that challenge of more frequent delivery. But we're going to get into deliveries in just a second. So moving to smaller containers is what we'd like to achieve. And I'll give you a verbal software design, if you like. We've seen some really nice tools for helping to manage containerization and the proper sizing of bins. I can just describe to you these Excel-based tools that we've seen and how they work. So picture this in your mind. You have an Excel workbook open, and one of the sheets is the standard containers approved for your facility. So you just list them out. You can give them a code, A, B, C, D, and you know for a limited selection of bins, these are the ones we're going to use in our factory. So that's very helpful, right? Limiting the variety of different bins that you have. And you have the size of each of those bins. So you have the height, the width, the depth of each of those bins. You know how many cubic inches each one will hold. So that's one worksheet. Next worksheet is you have all the items that you have to manage and fit into these bins. And for each of these items, you also know the size of the item, and there's one other factor that you have to consider, and that is the nesting capability of the parts. And so for some parts, it's zero nesting. You can't overlap them. But in others, they can fit together so that maybe in the space of one part, you could fit half of another one, that kind of thing. So nesting factor 1 would be 1 to 1. Nesting factor 1.5 would be I can fit 1.5 parts in the space of 1. So the nesting factor is going to be important. And then just do some arithmetic and take the actual space required and the bin container sizes and create some simple formulas and calculate the number of parts that can go into these bins. And you could even add a factor for weight. So you might be able to fit a certain number of parts in a bin, but the weight exceeds the recommended maximum for handling, which OSHA controls. I forget what it is, 30 something pounds, right? That you don't want an operator lifting a bin that's too heavy. So those kind of considerations could be built in. So we've seen tools very much like this that as I just described it, in use. And what that does for you is it saves a huge amount of time having to fool around and do this analysis. And doing it for a few items, not that big a deal, but we have thousands of parts in most cases that we have to manage. And so using simple tools like this to really accelerate the analysis process can be really super helpful.
And remember, what's the option? The option is you take your bins, you go to the floor, you fill, you shake the bin, and then you count how many parts fit. That is a long and arduous process. We've done it. We don't recommend you do it. So
yeah, multiply that by hundreds of parts or thousands of parts, and you've now burned weeks of time doing that. So,
and a really cool version of the tool that Richard was just describing was one that we've seen in one of our clients, where the system, which again was Excel-based, was tied to their CAD system, to their engineering design system, so they could retrieve part dimensions and nesting factors from the CAD system, and that saved them a huge amount of time.
Yeah, just enter a part number and hit this little macro button, and it would go off to their system and pull in that data in just a few seconds.
Yep.
And then the analysis didn't take much longer than that. And then a human being looked at the variety of suggestions and would make a decision. But the time it would take to analyze a part number was, I think, under 60 seconds, right, to do that. And they said it wasn't always perfect. Nothing is. But it captured probably 90% or more of what ended up being the correct container size. So pretty cool. Right? Next one. Next tool. If you don't mind, we'll move on. And this is the category of tools we call a plan for every part. Plan for every part. And what we're talking about here is typically Excel-based, and it is what it sounds like. We're creating a plan, a material management plan for every single item that you have to manage. Now, one thing you might ask yourself or say or challenge us on is, well, we already have that. We already have a plan for every part. It's called our ERP, MRP system. SAP, Oracle, it has all that information in it. And we would agree with you. Maybe not everything, but most of that information is in your ERP or MRP system. But here's the rub. Here's the catch. It's not all in one place. So if you look in your purchasing module, you can see some of that information related to a part, like your outside vendors and vendor lead times, those kind of things. And then you go to the item master and you can see some other information related to that part number, like the part number and the description and the weight and the cost, but not all of it, and so on and so forth. And you have inventory information, actual on-hand balances in a different module. So in other words, it's scattered all over the place, and you can't see it all in one place. So Can you extract information from your SAP or Oracle or ERP system? Sure. But let's put it in an easy-to-use format. And basically we're talking here about a humongous, massive spreadsheet.
A substantial spreadsheet, yes. Yeah. Lots of columns. Now,
with part numbers along the left.
Exactly.
And then across are all the columns for the types of data that we need to analyze a part and make some decisions.
And there's going to be a section of columns for sourcing data, planning codes, for dimensions, for ergonomic considerations, calculations. All of it goes there. And having everything in one place will allow you to make decisions a lot faster than having to retrieve multiple different screens from your ERP system.
And one of the pieces of information that you're probably not going to find in your ERP system is the Kanban sizing calculations.
Mm-hmm.
I can't remember seeing any ERP systems that really did it at least the way we teach it. I've seen some systems that have a field for Kanban quantity, but that's an input field, just a blank. You can type in anything you want there. Mm-hmm. It's not actually doing a calculation. So, things have improved in the world of software. Maybe that exists now. I haven't seen it. So there are some columns that don't exist in your ERP system. So you have this massive spreadsheet, which you can filter. You can hide columns, so it doesn't have to be overwhelming. But the idea here is to be able to analyze parts. And I have a great heartwarming story, at least for me, heartwarming, that I saw. I had a chance to visit a company that had gone to one of our material management classes. And I was hanging out with the lean group there, and I saw this monitor, and I kind of looked over their shoulder, and they were working on a plan for every part in Excel. And what they told me was, this was interesting. They were very excited about this because in the past they couldn't really tell what was going on exactly, but they created a spreadsheet with a column for the Kanban quantity and cost, the dollar value of that. So they did a Kanban calculation and they costed it out. So that's how much they should have based on the Kanban philosophy. And then they had actual. So currently on the factory floor or in the warehouse, how much did we have of this item? And then they just simply filtered or sorted based on the biggest discrepancy. And very quickly they could zero in on those items that had the widest variation from what they should have versus what they had in terms of savings. So very quickly, literally within a few days, they were able to zero in on the biggest offenders and start working on those. So I think this was another, I don't know if it was a Deming saying, but work on the biggest defilement first, right? Work on the biggest opportunities first. And that's what they were able to do. So that was great, seeing them use that tool and kind of as we just described it to you and getting some great results very quickly. All right, so that's called a plan for every part.
The next tool that we wanted to share with you is, if you think about putting together a Kanban system or a materials management system complete, and then you tell your material handlers, well, go figure it out, go deliver parts where they need them. It is very likely that you will fail, the system will fail. What the system needs is to have a standard, well-designed delivery routes. That's one of the tools we teach in class, and I think we have an entire lesson dedicated to that. I know we have an entire lesson dedicated to that. And that is very important because it will allow you to standardize the delivery of materials. And these delivery routes are not difficult to design, but they require that you do figure out some of those standards. The standard time to get on and off the transportation vehicle. Let's assume it's a tugger, so time to get on and off the tugger. The speed of the tugger to understand how fast it can go down the aisles. The precise route, where the tugger is going to turn right, where it's going to turn left, is not going to change from a cycle to cycle. That tugger is always on the same route. How much time it takes to pick up an empty container and deliver a full container. With all that, you will be able to calculate the number of tuggers you need per route, the number of routes you need, and the number of people you need to support those routes.
So think, when you're thinking about this, think about designing, imagine you're a city planner and you're designing a streetcar route. as opposed to having a fleet of taxis. Some factories are like a taxi-driven, and the taxi is the fork truck. So the fork trucks can drive all over the place, really flexible. They can carry big parts and heavy loads. Sometimes you need them. But that's not what we're talking about here. We're talking about a streetcar system that runs on a schedule, and that schedule's pretty often. We'll talk about that here in a second. And it runs on a fixed route. So if you're an operator out there on the floor, you can kind of expect that streetcar, meaning the tugger with some carts on it, to come by at a predictable frequency, right, every so often. Now, what should that frequency be? Well, that's up to you to decide, but here's the key. Here's the golden key to shortage-proofing your lines. So if you remember anything else, if you only remember this one thing in this lesson, you should remember this, that the golden key to shortage-proofing your line is the ratio between the inventory that you have at a point of use and how often you're able to replenish it. You don't have to replenish it at that frequency, but you can. So I'll just make up some numbers for you. If you have 4 hours of inventory at a workstation and your tugger comes around every 4 hours, you might think that's perfect. But if you consume that material any faster than every 4 hours, you're out. Okay, you've run out at that station. So not recommended. Now, if you have 4 hours, the same 4 hours at a station, and that tugger comes around every 2 hours, you can actually consume that material quite a bit faster than planned. Okay, you plan for 4 hours, but you can consume faster than that and still not risk being out at that location. So what we're saying here is your tugger route, your delivery routes, should be a fraction of the inventory that you have there, probably in the range of 4 to 1. And we've been places, and this is a company with a T in their name, that actually delivers material on a ratio of more like 8 to 1. And you can pretty much be guaranteed then, even in the face of variable usage, and you will have variable usage in a mixed model line, even in the face of that, you don't have to worry too much about the ability to cover variable usage, even in fairly extreme examples. So this is, the light bulb went on for me fairly recently in my lean career that this was really a key, because we saw it in action and eventually put 2 and 2 together. So having frequent deliveries allows you to have a small amount of inventory at the points of use and still give you that kind of coverage for variable usage.
And insulate your line against shortages.
Yeah.
That's what it will do. Now, don't be concerned about cost, because you have to look at the entire cost. This is really the best way to protect your line against shortages.
Yep. So, okay. So with that, let's move on. I think you have an opportunity here to apply any of those techniques: containerization, plan for every part, designing delivery routes. Pretty much with what we just shared with you. It's not that hard, but again, you need to have some focus time and put together a plan and go do that if you don't have that already. Okay, so we've covered a lot of exciting information in this lesson. Some of the main tools that characterize a lean material delivery system, lean material management. So with that, we'll leave you with a couple closing remarks. So in our very first lesson, we talked about why. This one we talked about what. And in the next lesson, lesson 3, we're going to talk about some more specific ways that you can actually get started. So the how. How do we actually do this? And part of the how is we're going to share with you some tools you can actually download. So pretty cool stuff. You'll be getting an email in a couple days, so look for that. Don't miss that. And we'll be sharing with you some of the actual templates that we use to actually do some of these things and kind of walk you through them. All right? So with that, continue your comments, post them on this page, and we'll look forward to seeing you in a couple days.
Excellent. Thank you. And please remember, let us know if you like it, you don't like it. Give us your comments. Give us your questions, because we will review them. We'll do the best we can to answer them. Thank you.
Okay.
Bye.
Bye now.